Hi dear students, let's see this question that came in JEE Advanced Paper 1 Physics in the year 2021. The question is based on the topic of rotation, more precisely rolling without slipping. The question is fairly simple, a regular question which most of the students are taught in their JEE Advanced preparation. Most of the students would have done this quite correctly. This was based on the multiple choice correct marking scheme. That means that there was partial marks also available for this question. So let's see what's happening over here. There's a cylinder. As of now, it is not being told in the question passage या question data में ये नहीं बताया गया है whether it's a solid or a hollow cylinder. There's a force F acting at the center in the horizontal direction, as you can see. The radius is r and mass is m. The cylinder, the coefficient of friction on the ground is mu, and there is no slipping at the bottom surface. Basically, we have to choose the correct option. Like first option says that the value of acceleration of the center will be independent of the fact whether this is a hollow or a solid cylinder. That means whether it's a solid or a hollow cylinder, value of A is going to remain same. This is option A. Option B is that maximum value of acceleration for a solid cylinder will be 2 mu g. Option C is friction value will remain constant mu mg for option C. And option D is for a thin walled hollow cylinder. That means for a solid hollow cylinder, value of A is will come out to be F by 2m. That is all. This is all what we have to find. Let's write the basic equations. If you uh, consider this as a cylinder, so force F is acting at the center in the horizontal direction. Friction will be acting in the backward direction. Okay. If you do not know that friction will act in the backward direction, you can also assume it to be in the forward direction. Ultimately, it will come out to be negative. Reality, there's a way to find whether friction is going to act backwards or forwards. Basically, if a horizontal force acts at a distance of I by mr square above, that means I by mr square. So compute this value. So for let's say for a solid cylinder, what is I? IC rather, I about center of mass. So what is IC? IC is uh, half mr square. So half mr square by mr square is half. So half into r. That means if r by 2 distance above the center से r by 2 distance ऊपर अगर ये force F लगता, तो force friction would have come in the forward direction. अगर center से r by 2 डिस्टेंस नीचे, दैट मीन्स जैसे ये पॉइंट r by 2 पे राइट, तो ये r by 2 से नीचे यहाँ पे अगर फोर्स लगेगा तो दिस फ्रिक्शन विल कम आउट टू बी इन द बैकवर्ड डायरेक्शन. So this is the way by which you can find whether the force friction will be in the backward or the forward direction. But this was not required for us. I just told you that that is an extra point. इसको भी clear कर देते हैं. Okay, so anyway, let's take friction as backward only, because in this case, as I told you, friction is going to be in the backward direction. If you write the torque equation about the bottom point, that is instantaneous axis, so torque of friction will be 0, torque of mg and normal will be 0, torque of pseudo force also will be 0, because for any person standing on this point is accelerated. Remember, this point has an acceleration in the upward direction. So for any person standing on this point, there will be a pseudo force, and it will go like this. Okay, pseudo force passes through center of mass, and it will be in the vertically downward direction. So this pseudo force is also passing through ICOR, and hence its torque will be 0 about ICOR. Therefore, we don't need to consider any torque. Only the force F is going to produce the torque about ICOR. So we can say that F into R will be is equals to IC plus MR square. This is the moment inertia about the bottom point, which is ICOR, instantaneous center of rotation, into alpha. Since the condition of pure rolling is satisfied, so we can write alpha as A by R. So from here you can see that A becomes FR square divided by IC plus MR square, right? Now this clearly shows you that acceleration A actually depends upon the fact whether it's a hollow or a solid cylinder, because for a solid cylinder the moment of inertia will be half mr square about center of mass, and for a hollow cylinder it will be mr square. Therefore A will be different. So option A is clearly wrong. For a thin wall hollow cylinder, we can also find option D using this. Uh, for hollow cylinder, just put the value of IC. So if you put the value of IC, it will become mr square. So it will become FR square upon mr square plus mr square will become 2mr square. So which becomes F by 2m. So option D, you can see uh, is correct. Option D is correct. Okay, option D सही हो जाएगा. Option B, for a solid cylinder, the maximum possible value of A is 2 mu g. Now, this we can find very easily by writing the torque about center of mass. About center of mass, torque of F will be 0, torque of normal will be 0, torque of mg will be 0. Only friction is going to produce the torque, right? Hence, we can say Fr into R will be equals to I about IC. For a solid cylinder, center of mass के about moment of inertia कितना होता है? Half mr square into alpha. Condition of pure rolling is satisfied, so R alpha को we can write AC. Okay, and 1 R will be remaining. Now it is very easy to see from this equation that अगर AC maximize करना है तो friction को maximum होना पड़ेगा. It's very easy to see. Hence friction को maximum कर देते हैं 2 FR upon m और friction की maximum value mu mg हो जाएगी. So that means A max की value कितनी आएगी? This is A max. A max is this. ये A max आ रहा है 2 mu g. Okay, and hence maximum acceleration is 2 mu g. Okay, so this is correct option. The magnitude of friction force on the object due to ground is mu mg. This will not always be correct because this is the maximum value of friction. We know that this friction is static in nature in the case of rolling without slipping. So this is the maximum value of the friction. This will not always be correct for values of F which are less than maximum possible value for pure rolling. The friction will be slightly less than mu mg. So we can say that means for pure rolling friction can be any value between 0 to mu mg. So this is not the exact value, like this will not always be the correct answer. This will be correct only if the friction becomes maximum. Okay, so we can say that this is not right, and hence B and D will be the correct answer for this question. That's it. I hope you would have understood. That's it. Thank you.